Hello, kiddo. Sir E is here, and this time, let's have the part two of our lesson on generator. And our main topic is the AC generator. In the previous video, we have learned about electromagnetic induction. And we know that induced currents are produced in that process. And if a straight conductor moves in a magnetic field, an EMF will be induced in the conductor. And for us to analyze the direction of the induced current in the electromagnetic induction, we use the Fleming's right-hand rule. So once more, it is used to know the direction of induced current. And it looks like this. Same with the Fleming's left-hand rule, we will use the three fingers, but this time in our right hand. So the thumb still represents the force or the direction of the movement. Then our pointing finger or forefinger will represent the magnetic field. And lastly, our middle finger will determine the direction of the induced current. This Fleming's right-hand rule is applied in alternating current generator or also known as AC generator. But first, let us describe what is an AC generator is. Pag sinabi nating alternating current generator or AC generator, it makes use of electromagnetic induction to convert mechanical energy into useful electrical energy. One form ng mechanical energy ay kinetic energy. So, ibig sabihin ay may movement, tapos sa movement na to ay makakaproduce tayo ng kuryente. That's why it is from mechanical to electrical energy. Paano nangyayari yon? Let us have the setup for AC generator. And basically, it looks like this. Let's describe the parts of an AC generator. So first, let's begin with the rectangular coil of wire. Sometimes it is also described as the armature. Second, we also have here permanent magnets. So we got the north on the left, then south on the right. Also, we have the split rings. Split rings are also called as commutator. And then these split rings are connected to these two carbon brushes. Kung natatandaan natin, sa DC motor, ang function ni armature or ng rectangular coil wire ay tama. Ito ay nagpo-produce ng turning effect. Pero dito sa AC generator, ang function nito ay mag-produce ng electric current in the form of alternating current. Isa pang comparison ay ang function ng carbon brushes. Sa DC motor, ang function ng carbon brushes ay mag-transfer ng direct current to the commutator or sa split ring. Kung naaalala ninyo, sa mga simple electric motor, kailangan natin ng kuryente para makaproduce ng magnetic field. At dahil sa interaction ng magnetic field ng coil at saka ng magnet, nagkakaroon tayo ng turning effect. Dito sa generator, ang function ng carbon brushes ay taga-transfer ng electric current in the form of alternating current into the external output. So, ibig sabihin, itong carbon brushes dito ay nakakonect sa isang external output kung saan magiging useful ang na-produce na electric energy or electrical energy. For example, meron tayong bulb na nakakonect dito sa generator natin or merong ibang appliance na nakakonect dito. So once na nakaproduce tayo ng electrical energy, ito ay gagana. So ganito nagwo-work yung generator. Para maunawaan natin ang process, let's proceed to the next slide. So basically, this is our setup for AC generator. So like what we have discussed a while ago, the components are here. The rectangular coil or the armature is labeled A, D on the side, then C, B on the other side. At tulad ng sabi ko, this system is connected to an external output, and in this case, our electrical load is a light bulb. Kung nakikita ninyo, ang rectangular coil ay nakakonect sa isang handle. So, ibig sabihin, minumove natin ang rectangular coil dito. So, meron tayong mechanical energy in the form of kinetic energy. And later on, kung nakita ninyo, nagkaroon ng changes sa position at kung titingnan natin ang electrical load, the bulb lights up or emits light. Thus, electric current is produced. Here's our setup. So we have to use the Fleming's right-hand rule to analyze this diagram or the setup. You have to take note that the plane of the coil of the wire is parallel to the magnetic field. At pag ganito ang posisyon ng ating coil, mas mataas yung current na napoproduce niya. Also, we have to take note that based on the diagram, the coil is rotated clockwise direction as indicated by this arrow. And with that, the induced current will flow in the wire in the direction A, D, to C, to B, and going to our external output. You would see later that as the coil is rotating clockwise, we will reach this position wherein the plane of the coil is perpendicular to the magnetic field. At kapag nasa position tayo na perpendicular to the magnetic field, there will be no induced current. Tatandaan ulit natin, kapag parallel ang coil sa magnetic field, it is the best position to produce the alternating current or electric current. While when the coil is perpendicular to the magnetic field, there's no induced current produced. And this is the principle used by AC generator. So we have here this setup, and this is described as a half of a revolution. And in here, there will be switching of sides. So we got A, B, and C, D. And we have to take note that the direction of the rotation remains the same, as well as the magnetic field. And so when we reach this part, as we apply the Fleming's right-hand rule, the induced current will flow now from B, C, D, A, and then going to our external output. And later on, it will reach this position again. So once more, it is perpendicular to the magnetic field. And with that, there will be no induced current flowing in our coil. And once we reach this is what we call one complete revolution. So how does an alternating current look like? We have this one. If you can still remember, this is our original position. So remember that if the coil is perpendicular to the magnetic field, then we produce induced current. Then if it is perpendicular, no induced current. Then we will have the halfway revolution. then back to the perpendicular, then complete revolution. So once more, this illustration shows one complete revolution. And when we check the produced voltage over time, makita natin na it will produce a pattern like this. That's why it is called alternating current. Induced current is produced, then none, then opposite. So there's reverse, but induced current is produced. Then number four, none, then we will produce induced current. So again, this is the so-called alternating current. How can we increase the magnitude of the induced current? So we can do the following. First, we can increase the number of turns in the coil. Second, we can use stronger permanent magnets. Third, we can wind the coil around a soft iron coil to increase the magnetic flux linking the coil. And lastly, we can also increase the frequency of rotation. So papabilisin natin yung pag-ikot ng, in that case, ng rectangular coil or ng armature. You have to take note that both the magnitude and frequency of the output voltage will be increased if the frequency of rotation increases. Another method that we can use for generator is what we call fixed coil generator. Kung naalala ninyo, doon sa example na binigay, yung coil yung iniikot natin. Pero dito, we will make it fixed or stationary. So sir, paano po gagana yung generator na to kung hindi gumagalaw yung coil? So instead, what we will have is a rotating magnet. So we will have the opposite one. And again, this is what we call fixed coil generator. This is used to power the bicycle lights. So here's the setup for fixed coil generator. So number one, the magnet is connected to an axle and rotating wheel. As the wheel rotates, the magnet also turns. So we have here. So this is our axle, then this is our rotating magnet. Ulit, sa fixed coil generator, ang magnet ang nagro-rotate. Second, the magnetic field lines linking the coil change as the magnet rotates. And with that, we induce EMF. Third, the induced EMF causes a current to flow through the output terminals to the load. And usually, dahil nga nakikita natin to sa mga bicycle dynamos, then it lights up the headlights of this bicycle. So what are the advantages of a fixed coil generator? First, it is more compact. Second, it does not require carbon brushes katulad nung kaninang diniscuss natin. Ang kinaganda ng walang carbon brushes ay may iwasan natin ang breakdown ng buong system due to overheating. Kung tatandaan ninyo, magka-connect ang split ring commutator and also the carbon brushes. And so, nagkakaroon lagi ng friction na nagkukos ng eroding parts or pagkasira ng mga parts nito. And lastly, we can increase the resistance and so there will be less heat produced. And these are the references used for this PowerPoint. And that's it. We are done. I hope you understood the lesson on AC generator. I will see you again in my next Teach Vlog. Bye-bye. God bless.
Thanks for watching. Please don't forget to like, share, and subscribe.